Okay, so for this next part, we're going to talk about the coordinates. So we already have our coordinates for our quadrant points, so like the x and the y-axis, all right? So now we're going to talk about how do you figure out what the coordinates are for all these points that are, so like these are easy to figure out because you're 1 unit away, because it's a circle with a radius of 1. But when you're going diagonally, you have to figure out where would that land, okay? So what you do, or what you get that from, is from special right triangles, all right? So this point right here, let's look at this one, all right? If you think of it like a right triangle that looks like this. So here's the 90-degree angle over here. The hypotenuse is this piece, the radius of the circle, okay? So if you notice, since the hypotenuse is the radius of the circle, we already know this has a radius of 1. Okay, so this is a length of 1. All right, and so when you're doing special right triangles, basically what ends up happening with these is that you need to figure out what angles you're working with. So this first angle on the unit circle was 30 degrees. So that means this piece is 30. This has to be 60 since this is 90. Add up to 180. All right, so when you're doing with special right triangles and you're working with trig, all that, you end up finding out that this piece is 1/2, and this piece down here is the square root of 3 over 2. So it works for the Pythagorean theorem, trigonometry all works out. Okay, so when you're trying to pull out these points, it's just how far you went on the x-axis and how far you went on the y-axis. So this point, this is your x, this is your y. This point's located at the square root of 3 over 2, 1/2. Okay, so that helps you find your first point. So now, when we're looking at this piece, so our first 45-degree angle part. So you're doing the same thing. You've got a triangle. Let me do a different color here. All right, so this triangle, right, it also has a hypotenuse of 1, okay, because it's the radius of the unit circle. But our angles this time are 45, 45, and 90. Okay, so when you have special right triangles that are like this, that are isosceles, with both of these being 45, what ends up happening is this is the square root of 2 over 2, and this is the square root of 2 over 2 for the Pythagorean theorem to work out, and you get 1 for the hypotenuse. So you went over square root 2 over 2, up square root 2 over 2. So that is where those numbers come from. All right, so then the last one, let's find a color that's going to stand out. All right, so with the last one, this triangle, going all the way up to this point and coming over. All right, so it also has a hypotenuse of 1. Here's the 90-degree angle in this triangle. All right, so this angle on the unit circle was 60, so that means down here this part is 60, and this little angle up here is 30. Okay, so we have the same triangle, this orange one from earlier, it's just been like flipped over. All right, so the long piece is still square root 3 over 2, and the short piece down here, so this part, is still 1/2. So now that we're at this coordinate, we only went over 1/2, and then we went up square root 3 over 2. So 1/2 square root of 3 over 2. So that is where all of these numbers, these fractions are coming from. It's from these 3 special right triangles. And then all you have to do is just think about the fact that the triangle is going to be flipping over and reflecting across the x and y axis as you go around the circle. So when you're plotting these points, okay, this is the exact same height and distance away from the center. It's only in the negative direction now. So this is going to be negative 1/2 square root of 3 over 2. This point, same height as this one, same distance away, but it's in the negative x's. So negative square root of 2 over 2, square root 2 over 2. All right, this one matches up to this point. So you have negative square root of 3 over 2, positive 1/2. All right, and then now when you go down here, you're just flipping them down here, so they're going to have negative y's and positive x's on this side. So this point matches up to our orange one right here. So it's going to be square root of 3 over 2, negative 1/2. This one, you're going to have square root 2 over 2, negative square root 2 over 2. And then this final point over here is going to be 1/2, negative square root 3 over 2. This side, this quadrant, reflects these guys down here, and it's going to have negative x's and negative y's. So you've got negative square root 3 over 2, negative 1/2, negative square root 2 over 2, negative square root 2 over 2, negative 1/2, negative square root 3 over 2. Okay, so once you can do that and you can draw it all out, now you know the answer to the sine and cosine trig stuff that they want you to know in the exam without a calculator. So cosine, let's see here, let me erase this part and I'll write it in here. Alright, so cosine is your x values. Okay, so all of the first numbers, the x values, that's your cosine. So if I was like, what is cosine of 30 degrees? So 30 degrees is the first mark on the unit circle, so cosine of 30 degrees is square root 3 over 2. If I wanted to know what is cosine of 120 degrees, 120 is way over here, and that would be negative 1/2. So first value is your cosine. Alright? Sine is the y values. Okay, so your second numbers tell you what sine is. Right, so if somebody wants to know what is sine of 90 degrees, it would be 1. If somebody wants to know what sine of 45 degrees, it's square root of 2 over 2. Okay, so that helps you figure out what cosine and sine are going to be without using your calculator. And you'll need to have those memorized, but if you can draw the unit circle, you've got it memorized. And then you can just plot those points to graph and make the curves. So that is how to memorize and figure out the whole unit circle from scratch.